It is capable of setting ordinary water on fire. It is capable of dissolving thick glass and turning iron into ash in a matter of minutes. It has no friends in the periodic table, only victims. This is the most aggressive, unpredictable, and hazardous element the universe has ever forged. Its name is fluorine, the ultimate chemical annihilator. For centuries, it remained an invisible ghost. The scientists who tried to look it in the face paid for it with their health, their eyesight, and their lives. History called them the martyrs of fluorine, and the gas itself was branded the alchemist's curse. But today, this monster is working for you. It helped humanity build the atomic bomb, and then by pure accident gifted us Teflon frying pans and spacesuits. Right now, it is guarding your teeth from decay, but exceed the dose by even a single milligram, and it will start dissolving your bones from the inside out. How did humanity manage to trap this hellish gas inside a platinum cage? And what price do we pay to use it? Fasten your seatbelts. This is the complete story of fluorine. Let's roll. Imagine a chemical element capable of setting ordinary water on fire, dissolving thick glass in mere minutes, and turning iron or steel into a pile of pale ash. This is no invention of science fiction writers or comic book creators. This is the reality of our periodic table. Its name is fluorine, the absolute psychopath and sadist of the elements, hardwired to rip apart any compound it can get its hands on. Its story begins in a vast wilderness, hard to even conceive, not on Earth, but in the very hearts of dying giant stars. You see, unlike iron, carbon, or oxygen, which our universe churns out by the billions of tons during the standard life cycle of a star, fluorine is an absolute cosmic scarcity. Its atomic nuclei are incredibly fragile. They are instantly obliterated in ordinary stellar nuclear reactions almost as soon as they manage to form. Most of the fluorine currently present on our planet was born under extreme conditions, the result of rare, colossal supernova explosions, or deep within the boiling interiors of so-called carbon stars at the very end of their life cycles. It was quite literally spat out into space during cosmic catastrophes. To understand its sheer isolation, one must realize that fluorine is a cosmic lone wolf. While elements like carbon build the backbones of life, and oxygen binds planets together, fluorine wanders the universe as a rare, volatile byproduct of stellar death. When the dust from these ancient cosmic explosions finally coalesced to form the Earth, fluorine did not settle quietly into the crust. It immediately locked itself into the planet's deepest minerals, hiding like a trapped demon inside rocks, waiting for someone foolish enough to try and break its bonds. Once isolated in a laboratory, this cosmic drifter reveals its true, terrifying face. In its pure form, fluorine is a pale yellow gas with a sharp, suffocating odor. But seeing it in this state in the wild is absolutely impossible. Fluorine possesses a maniacal, almost chemically insane drive to rip electrons away from any other substance that crosses its path. It doesn't merely react, it annihilates. Fluorine forces water to burn with a beautiful but deadly blue flame, violently displacing its oxygen. It instantly attacks almost all metals, and under the right conditions, it can even corrupt noble gold and entirely inert gases like xenon, which normally refuse to bond with anything. It is the ultimate chemical predator, an apex aggressor that humanity could not simply capture. It took centuries of bloody, blinding attempts just to look this gas in the face. As the 19th century dawned, the race to isolate this invisible ghost turned into a real-world scientific horror story. Chemists knew a monster was hiding inside fluoride, but every attempt to break it free became a biological catastrophe for the researchers involved. To understand the terror it struck into the scientific community, one must look at the sheer unpredictability of its acid form, hydrofluoric acid. Unlike strong acids that burn skin instantly on contact, giving an immediate warning, this insidious substance can seep through tissues without causing initial pain. It travels deep into the body, aggressively seeking out calcium, literally dissolving a scientist's bones from the inside out while leaving the surface skin deceptively intact. It was a phantom assassin operating in the dark. Furthermore, early laboratories were completely unequipped for this level of chemical warfare. There were no rubber gloves, no fume hoods, and no plastic containers. Since fluorine easily eats through glass, scientists were forced to work with heavy, opaque vessels made of lead, silver, or platinum. This meant they were operating completely blind, unable to see the reactions taking place inside, relying only on their senses and their luck. Every turn of a valve or opening of a container was a gamble with fate, transforming quiet academic rooms into high-stakes minefields where a single whiff of an invisible vapor could seal a man's doom. The Irish scientists, brothers Thomas and George Knox, attempted to outsmart the gas by constructing an apparatus entirely out of fluorite itself, hoping the parent material could withstand its own offspring. The result was disastrous. Both brothers suffered severe poisoning from hydrofluoric acid vapors. Thomas was completely bedridden and incapacitated for 3 years, while George was left with permanently ruined lungs and a shattered constitution for the rest of his days. The brilliant British chemist and inventor George Gore nearly lost his life in his own laboratory. He attempted to isolate fluorine using electrical currents, but the pale yellow gas instantly found a microscopic trace of hydrogen in the system. A violent explosion tore the apparatus to shreds, and Gore only miraculously escaped being killed by the flying shards of glass. But French chemists Jerome Nicolas and Charles Luyet were not so fortunate. They paid the ultimate price for scientific progress. Working with hydrofluoric vapors without any of the protective gear that we take for granted today, they inhaled a critical dose and died in agony from toxic pulmonary edema, their lungs overproducing fluids, until they literally drowned from the inside out. Fluorine punished every mistake, every miscalculation, and the sheer arrogance of anyone who dared to disturb its peace. By June 1886, Paris had become the epicenter of this desperate chemical war. A brilliant French chemist named Henri Moissan looked at the long, grim list of his maimed and deceased predecessors and realized a brutal truth. Classical chemistry was utterly useless against this element. You could not force another substance to displace fluorine from its compounds because fluorine was inherently stronger than any chemical agent on Earth. It would simply annihilate the reactant and melt the very vessel housing the experiment. Moissan knew that if he wanted to drag this monster into the light, he had to abandon traditional methods and resort to the raw, brute force of electricity paired with physics at its absolute extreme. He understood that the only way to tear fluorine away from its tight chemical grip on other elements was through electrolysis passing a powerful electric current through a liquid solution. But what could possibly hold such a reaction? Moissan drained his finances and commissioned a custom U-shaped apparatus forged entirely from pure, precious platinum. It was one of the few metals on Earth capable of withstanding the gas's ferocious appetite, if only for a limited time. Yet, even platinum wasn't enough on its own. To survive the onslaught, Moissan decided to put the monster to sleep. He submerged the entire platinum apparatus into a specialized cooling bath of liquid methyl chloride, plunging the temperature down to an extreme around -9 degrees Fahrenheit. At this freezing threshold, fluorine grew sluggish, stripped of the thermal energy that fueled its chaotic rage. With the trap set, Moissan filled the platinum tube with a volatile mixture of liquid anhydrous hydrofluoric acid and potassium bifluoride to allow the electric current to flow. He threw the switch, the voltage surged through the frozen chamber, the laboratory held its breath, and then, at the positive platinum electrode, tiny, pale yellow bubbles began to slowly form and drift upward. it was finally here. The mythical, elusive, pure fluorine gas, isolated and captured for the very first time in human history. But this historic breakthrough demanded a heavy, deeply personal tax. When Moissan proudly stepped before his colleagues at the French Academy of Sciences to demonstrate his captured predator, he did so wearing a thick, black patch over his face. The relentless leaks and toxic exposure throughout his grueling trials had severely burned his tissue, costing him the sight in his left eye and permanently shattering his overall health. Yet, the beast was finally locked inside its platinum cage. This unparalleled act of scientific courage earned Moissan the ultimate recognition, the 1906 Nobel Prize in Chemistry, and etched his name forever into the annals of human triumph. In the 20th century, fluorine broke out of the quiet confines of research laboratories and exploded onto the industrial stage, instantly revealing its deeply terrifying dual nature. It became the chemical embodiment of the mythical god Janus. With one face, it served as the driving force behind the darkest, most destructive weapons humanity has ever engineered. With the other, it became the architect of unparalleled everyday convenience, creating materials that redefine modern civilization. Its dark military chapter began in the absolute secrecy of World War II, when the American Manhattan Project was launched to construct the world's first atomic bomb. Scientists hit a monumental technical wall. They needed to separate two nearly identical versions of uranium, uranium-235 and uranium-238. Because their chemical properties are completely indistinguishable, the only way to separate them was through a physical process called gaseous diffusion. But uranium is a heavy, dense metal. How do you turn a solid metal into a gas? The only compound on Earth that allowed for this magic trick was uranium hexafluoride, or simply hex. Fluorine became the indispensable key that unlocked the atomic age. Without millions of tons of this hyper-aggressive gas to process nuclear fuel, the creation of the atomic bomb and the dawn of nuclear energy would have been flatly impossible. Yet, at that very same historic crossroads, this untamable element accidentally gifted the world a domestic miracle. In 1938, a young chemist named Roy Plunkett was experimenting with refrigerant gases inside pressurized cylinders. When he opened a seemingly empty tank, he discovered that the gas had spontaneously transformed into a strange, slippery, white powder. This substance was polytetrafluoroethylene, known to every household today by its brand name, Teflon. Scientists soon discovered that the chemical bond forged between carbon and fluorine within this polymer is one of the strongest, most unyielding forces in the known universe. Teflon proved utterly bulletproof against the environment. It cannot be dissolved by the strongest acids. It refuses to burn. It withstands extreme temperatures, and its surface friction is so incredibly low that almost nothing can stick to it. Today, this unique material born from the world's most aggressive predator coats our kitchen pans, lines life-saving medical implants inside the human body, and shields multi-layered astronaut spacesuits from cosmic radiation and the vacuum of space. Fluorine completed an unbelievable journey, from the heart of weapons of mass destruction straight to the morning eggs cooking on your stove. Today, as we go about our daily lives, fluorine continues its relentless work, but it no longer operates as a visible monster in a laboratory. Instead, it has become the invisible architect of our own bodies. In microscopic, trace amounts, this former chemical predator works as a silent, hidden superhero standing guard over our health. Our teeth and bones are not solid, indestructible monoliths. They are made of a complex, porous mineral called hydroxyapatite. While this structure is strong enough for daily life, it possesses a critical vulnerability. It is easily dissolved by the weak acids produced by bacteria in our mouths whenever we consume sugars or carbohydrates. This chemical vulnerability was a historic curse for humanity, leading to widespread dental decay for centuries. But this is exactly where our untamed element steps onto the stage. When fluorine enters the human body in precisely measured, optimal doses, whether through fluoridated drinking water, specific foods, or ordinary toothpaste, it begins a brilliant molecular reconstruction. The hyperreactive fluorine atoms quite literally ambush the crystal lattice of our enamel, displacing the weaker hydroxyl groups and transforming the mineral structure into a completely new compound, fluorapatite. This newly forged structure acts as a literal chemical suit of armor for your teeth. Fluorapatite is significantly more resistant to acidic environments, refusing to let bacterial acids breach the protective walls of the enamel. By seamlessly reinforcing this defense, fluorine has practically saved modern civilization from chronic, agonizing decay, preserving our smiles in a way nature alone could not. Yet, never forget that this tamed predator is merely sleeping, and its true chaotic nature has not vanished. The boundary between salvation and catastrophe in the kingdom of fluorine is razor thin. If you exceed the safe daily limit by even a fraction, the superhero instantly reverts into a ruthless destroyer. An overabundance of fluorine triggers a destructive systemic reversal known as fluorosis. Instead of protecting the body, the excess element turns against it. Teeth lose their strength, become covered in mottled, chalky brown stains, and begin to crumble like brittle plaster. Deep within the body, the skeletal frame weakens, turning bones so fragile that they snap under the slightest stress. Fluorine has never forgiven, and will never forgive, a mistake in dosage. It remains the exact same dangerous, hyperreactive, and explosive element that we have learned to cleverly exploit, but have never truly conquered. The story of fluorine is more than just a tale of chemical formulas and volatile reactions. It is a testament to human persistence. It's about how step by step, through trials, catastrophic errors, and the lives of the world's finest minds, we wrestled nature's darkest secrets from its grip. Fluorine never became docile or safe. It remains that exact same cosmic lone wolf, forever primed to tear apart any atomic bond it touches. Yet, humanity forced it to work. We balance on a razor's edge between nuclear threats and domestic convenience, between bone destruction and dental protection. And this balance is the very essence of our civilization. We don't fully conquer monsters. We simply learn to keep them caged, harnessing their raw power to drive ourselves forward. Thank you for watching. If you enjoyed this chemical thriller, smash that like button, subscribe to the channel, and let us know in the comments which element of the periodic table you want to uncover next. There are plenty of mind-blowing stories ahead. See you in the next episode.